Let's say you see this kind of a simple question in your chemistry jam exam. How will you solve it? This is very simple. Let us solve it together. The question says, what is the electronic configuration of the element with an atomic number of 37? That is X subscript 37. They are trying to tell us that this particular element has an atomic number of 37. And that means that it will have 37 electrons, right? So now what they are asking us for is the electronic configuration. That is how the electrons are arranged in the shells and the subshells or the orbitals. So now let me try to tell you guys one simple thing that you should know. When you talk about orbitals, you should know that we are talking about the s, p, df orbital. That is the sharp, principal, diffuse, and fundamental orbitals. And each of these orbitals has a maximum number of electrons that can be in them. For x orbitals can only take a maximum of 2 electrons. For p orbitals can only take a maximum of 6 electrons. For d orbitals can only take a maximum of 10 electrons. And for f orbital can only take a maximum of 14 electrons. Don't forget all of this because all of these numbers are quite important to write our electronic configuration. So now we want to know how the electrons are divided into the subshells and even the shells. When I talk about the shell, I talk about the principal quantum number, that is the K, L, M, N shell. That's our first shell, second shell, third shell, and so on. So now I want to give you guys a simple diagram that you can use to be getting your electronic configuration, that is using Aufbau principle, right? So this Aufbau principle, it actually has some exceptions because some elements they don't usually have their own electronic configuration like that. Elements like chromium, copper, gold, or even silver, they don't usually conform to the off-bar principle of electronic configuration because of sometimes it's usually the jumping of electrons, and sometimes or most times the D and the F block elements, most of them or some of them don't usually conform to the off-bar principle. So let me try to write this diagram or draw this diagram so that you can know 1s, 2s, 3s, 4s, 5s, 6x, then 2p, 3p, 4p, 5p, 6p, then 3d, 4d, 5d, 6d, then 4f, 5f, then 6f. It's more than this, you can do it as much as you want. But for this particular element, I'll just stop here. So you just have to do the arrow like this. Try to make an arrow like this. This is just showing the direction of how the electrons will be filling in the shells and the orbitals. You understand? So it goes in this manner. Just you can do it as much as you want, depending on how sophisticated the element you want to write the electronic configuration is. So now the element you want to write the electronic configuration for is having an atomic number of 37, right? 37, that means it has 37 electrons. So we just need to be filling in the electrons from the first shell and the first orbital. So here we are starting from our 1s. So we write 1s. What is the maximum number of electrons that can be in the first shell? In the orbital, s orbital, that's 2. Then we move to the next one, 2s. Let's just continue. Then 2s, 2 also. Then we move to this. We are following this arrow, 2p, 2p, that's 6. 6 is the maximum. We will do it until we get to 37. That is when we will stop. So 2p, then 3s, 3, sorry, 3s2. Then we go to 3p, 3p6. Then we go to 4x, 4x2. How many are we like this? Let us count the number of electrons. 2, 4, 10, 12, 12 plus 6, that's 18. This is 20. So we need to continue till we get to 37. We are at 20 like this and we are at 4s. So this is 4x. Then 3d. D will take a maximum of 10 electrons. So 3d 10. So we are already at 30 like that, right? We are already at 30. Then 4p6, right? 4p6. We are following this direction. Then 4p6. We're already at 36. Then 5x. I think we only need one more since we're already at 36, right? And S usually take two electrons, and we just need one. So it will be 5s1. So this is the electronic configuration of this particular element. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Sorry, this 10 is supposed to be at the top. Oh, I'm sorry. 3d10, 4p6, and then 5x1. You understand? So what element is this element self with the atomic number of 37? Which element has an atomic number of 37? Correct. The answer is rubidium. Rubidium. So I want to give you guys an assignment. You guys should write the electronic configuration of the elements with an atomic number of 19. Write it in the comments. Solve it and write the answer in the comments. I hope this is very simple to understand. If you have any questions, you can send them in the comments, and I will see you guys in the next one. Peace out.